So today we are going to understand first thing first, which we also call it as mixing of different liquids, mixture of different liquids, and then I will move with the concept of Archimedes principle and all. Okay. So give the heading mixture of different liquids, or you can say ideal liquids. Okay. Yeah, ideal does not mean only incompressible. Ideal has, I have already discussed, ideal will. Huh. Hmm. It is just not non-viscous. Three properties are there: streamlined, non-viscous, and incompressible. Okay. Okay. So let's suppose I have case one where I have two liquids. Okay, and they are mixed together. Two liquids of density rho one and rho two respectively are mixed together, and their volume is given of volumes V1 and V2. Is that clear? So when I will mix them, what will happen? The net density of the resultant mixture uh, mixture is basically simple. It will be total mass by total volume, isn't it? But what is, since mass is not known to us, I can write this in terms of density. M1 is just simply rho 1 V1, uh, rho 2 V2 divided by V1 plus V2, and this is my density of resultant mixture. Are you able to get me or not? Similarly, case 2, two liquids, पानी में गई, छपाक छपाक. Okay, did you watch this reel or not? दो मछली पानी में गई, छपाक. हाँ, Instagram link. I think Instagram is banned in Dubai, no? Oh, okay, okay, okay. So two liquids, rho 1 and rho 2 are mixed together of okay, of masses m1 and m2. So basically, once again, the density of the resultant mixture is once again, it is going to be m1 plus m2 divided by v1 plus v2, but volume is not known. Yeah, but volume is not known. So m1 plus m2, v1 will be rho 1 by sorry, what it will be? v1 will be m1 by rho 1 plus m2 by rho 2. Take the LCM and it will be density of resultant mixture is equal to m1 plus m2 into rho 1 rho 2 divided by m1 rho 2 plus m2 rho 1. So this is the properties when two liquids are mixed together of different masses or different volumes. Are you able to get me or not? We are going to utilize this forms little bit later on, where we will talk about many things and we'll see that. Okay. Now, next thing is Archimedes principle. We have a lot of discussion regarding that, but once again we'll start from scratch of this. Okay, because that was just a description, but today we will see what actually happens. अब देखो एक बात बताओ, मतलब न्यूटन सॉरी आर्किमिडीज बाबा ने एक एक्सपेरिमेंट किया. उन्होंने क्या किया, वो सुबह सुबह बाथरूम गए. We all go to bathroom in the morning, and bathroom is a great place of thinking, isn't it? Yeah, so at that time, at that age, there was no mobile phone. So people used to think more, a lot more in the bathroom. So what he was doing bathroom, and then he was just taking a bath, and then he just dropped a mug inside it. So what he observed, that instead of going down, that mug was upwards, but some of the other objects started going down, started sinking. And then he got the idea that some things are insinkable, some things are sinkable. But he didn't give the numerical formulation of that. The numerical formulations was provided later on by different scientists. And but before that, he was just he gave the law of flotation, means which of the things can float and which of the things cannot float. Okay, but even that was a basic building procedure. Okay, people see, I'm not saying that this thing was not utilized. Like in India also at that time there were many goldsmiths who were using different things. So they were utilizing this process, but that process as a crude mathematics or crude description was provided by Archimedes. So Archimedes got the name that he is the director of law of flotation. Are you able to get me or not? Is that clear? So what he told, let's suppose if there is an body, any kind of a random body, random shape. Let's suppose I take a random shape. Uh, 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 let us just take like this way. It's dipped inside the water, void or not, or not even that. Let's just take this random shape. So this is the body which is immersed. Got it? Now you see that it's not fully immersed. Some of the volume is still left out, isn't it? This is the volume which is immersed inside the water. Are you able to get me or not? So then, yeah. So then, Archimedes gave this principle that let's suppose if the volume immersed is VIM, I'm representing immersed volume as VIM, volume of immersed liquid inside the water. Sorry, inside the water is not a good idea to write. Volume of object, sorry, volume of object. Uh, okay, and let's suppose if density of the liquid is given as rho, density of liquid. Then actually to describe this phenomenon, he did two or three experiments. What he actually did, that he took a boat, okay, he took a boat and he put it a load, okay, of some mass, and then means first he found out that means the boat was immersed till this level, okay, and then also he increased some of the weight, increased a little bit of its weight. He found out that there is no such a significance immersion, means the immersion was not that much significant enough, right or not? Means the boat didn't went that much down, but when he just, yeah, when he just reduced the shape of that boat, what he found out, that although with this much volume, this much mass, the water level was very high. Okay, are you able to get me or not? Means this boat was going down and down. So from here, he actually got this conclusion that the mass of the bodies are not the actual factor of measuring whether they will sink or not. Actually, the volume of the object which is immersed inside the liquid, that is the actual measure of a particular force or particular law of flotation or something like that. Are you able to get me or not? And based upon this, as this body is floating, see, try to understand, the body weight is downwards, the full body weight is downwards, but although it is not going down, that means some of the force is acting upwards, and he gave that force name as buoyancy force. FB is called as, yeah, force of buoyancy. Are you able to get me or not? And then he told this force of buoyancy is nothing but it is rho density of the liquid into not the full volume, the volume which is immersed inside the liquid into the gravity G. And this is called as Archimedes principle. Is that clear or not? Okay. Now, second point, we might think that this force is appearing due to the mg concept, but that is not true. This force is appearing. This force is the net force. No. Yeah. This force is not the force due to mg. This force is the net force due to pressure of the liquid air interface. Word or not? It's not the force which is appearing due to a particular concept of mg. Whenever you are going to write the buoyancy force equation, always think of pressure in your mind. Never ever think mg is getting balanced. Okay. Sorry. Never ever think that pressure is getting balanced. Okay. Sorry, never ever think that mg is getting balanced. It's just the force due to my pressure variation. It's not the force which is appearing with respect to mg. Think always that if pressure is more inside the liquid and due to that force per unit area is increasing. Are you able to get me or not? Yeah, mgs. You can say mg is very trivial. Yeah, you can say mg is very trivial. Okay. Yeah, no, we are going to consider mg, but this net force is not appearing due to mg. This force is appearing due to the pressure. Remove the liquid, there is no force. Are you able to get me or not? No. Just you remember one thing. See, I'll write this statement, then you will get to know. Force of buoyancy is the trick to calculate the net force exerted by exerted by the liquid on object due to liquid pressure. If there is no liquid pressure, then this force is of no use. You only think. See, pressure is given as what? Rho into H into gravity Z. Yes, isn't it? Now, pressure is also force by area. So this force which this liquid is applying on this body, this pressure which this liquid is applying can be written in terms of force, and that force is called as buoyancy force, which is equal to rho into area into height into gravity z. But what is area into height? That is nothing but rho of liquid volume which is, yeah, volume which is immersed, and gravity z. So that is why I said that force of buoyancy is nothing but a force equation which is based upon pressure, not on the balancing of energy. Are you able to get me on that? Is that clear? मेरी बातें समझ में आ रही है ना? ठीक. So look over there. Let's take an example. Let's suppose I have one container. Okay. Inside that I have a block. I just filled that with a block and the liquid is there. Okay. Let's suppose liquid level is still over here. Got it. Now बोल रहा है क्वेश्चन there is an wooden block, sorry, wooden block and an iron block. एक ही है, मतलब एक ही से हम मान रहे हैं, and wooden block and an iron block of same dimensions, of same dimension. Okay, released inside the water, are released inside the water as shown. Take. So let's suppose if the density was given by the equation sigma, okay, then tell the what you will observe in this question. Tell the observation, explain the observation. Explain the observations which will be observed in this experiment. Means एक वुडन ब्लॉक लिया जिसकी डेंसिटी सिग्मा हो और एक आयरन ब्लॉक लिया जिसकी भी डेंसिटी सिग्मा हो, सेम डायमेंशन है, और उनको दोनों को रिलीज किया, तो व्हाट यू विल ऑब्जर्व? Yes, so simple. First rule that we will see, wooden block moves upwards while while iron block moves downwards, isn't it? Because we know that in simple sense density of wood is less than density of water, and we'll see that understanding how this appears, isn't it? And let's suppose the density of liquid is rho. Acha, this is my first conclusion. Tell me about buoyancy force. On whom buoyancy force is bigger? That is the misconception. Actually, buoyancy force is same on both the blocks. We'll come on that. You only tell me. Buoyancy force has formula what? Fp is equal to rho v. It is independent of sigma, isn't it? The reason for that is for wood, mg is basically less than buoyancy force, but for iron, mg is greater than buoyancy force, and that is why, yeah, you can't say related to mass. You can't say anything about mass because mass is not given to us. It's just the factor which is more. The whole factor mg. It's not just the mass. It's just not just weight. It's just not the mass. It's the weight of the bodies are more and less. You have to say about weight, not the mass. Even if I take a wood of mass 5 kg and if I take a iron block of mass 5 kg, iron block will sink downwards while wooden block will come front in upwards. Okay. So, right as an exception, mass does not provide any conclusion. It contributes definitely. It's the relative, it is the relative weight inside water. Relative weight means effective G value inside the water. Are you able to get me? Okay, so based upon this, we'll talk more. But once again, let us just understand one more conclusion of this. And the conclusion is, let us just try to see one case, one peculiar case, where I took two different blocks. One of one is a wood and another one is a iron block. Okay. And I just melted them together. I just melted them together and I put it them inside the water. Means I just melted, means I just made, combined them together. Okay. Forged them together in a perfect sense. And then I put it them in water or liquid, any liquid. Got it? Then you tell me from where mg is working and where, draw the free body diagram of the body. Just draw the free body diagram. Think, think about that case. This is wood and this is iron. Okay, right, in a simple way, wood and this is iron. Now look over there. Although they have same dimensions, wooden block. The point is, wooden block have, first point is same dimension as iron block. Now you know that the density of iron is more, isn't it? So what will happen? The mg, which works, you only say me, the mg will work from the center of mass or not? So the mass of iron block will be more. Exactly. So mg will work from where? Center of mass. The first conclusion is whatever happens, total mg still works from, no, total mg still works from center of mass, isn't it? But the point is, although the mg, total mg I have written, but the total buoyancy force will be appeared only at any one random point, isn't it? The conclusion is this, this buoyancy force is always present at the geometrical center of the objects. Where it will be present? Then no, I'm just telling you that whatever means you have to take this whole body as one single body and then you have to appear, make your the buoyancy force to appear at geometrical center. It's not from the center of mass, and this is why we say that the buoyancy, we define one concept which we call as center of buoyancy, COB. Buoyancy, BUO, buoyancy. Okay, which is the point of application of buoyant force. Yes, and which is nowhere but at the geometrical center. Now look over here. Now as it is present at the geometrical center, now you can see that due to that there is a distance present over here between the geometrical center and the center of center of mass and center of buoyancy or not. So this is why whenever there is a composite material which is dipped inside the water, it actually rotates. It will rotate because there is a torque which is generated over here. Are you able to get me or not? Is that clear? And this makes the body to rotate. This body will rotate and then it will go down. Means this body will go spinning like this way and it will go down. Are you able to get me or not? Are you able to understand me? And this is why we need to determine or we need to express the answer of buoyancy force. Is that clear? Why? Simple, baba. There is a torque due to mg or not? I didn't have taught rotational motion to you yet, so just remember that there is a gap between two forces, one upward force and one downward force. This is why it will rotate. Is that clear? Is that clear or not? Next thing you need to understand, that day we were discussing something related to bucket, isn't it? Yeah. So if I have a liquid filled till some level inside this bucket, okay, let's suppose the liquid is till this level, then we told that we expressed that the 1 minute, I think this level will not be there. Okay, we expressed that the particular force from the curved surface of the this bucket is actually is in upward direction. There is a reason for that. There is a reason for that. You see that curved surface is due to the normal of this bucket or not? Yes. So from all the sides, it will be from the normal direction. Now look over here. The normal has two components, one along the horizontal and one along the vertical, isn't it? So look over there. When you observe that, out of all these normals, the normal along this horizontal component, along this horizontal direction, they will be in form of this or not. So they will cancel each other if it is a perfect curved surface. So which normal is left actually? The total normal, which is normal. So the sum of all the vertical normals, sum of all normal is nothing but a resultant vertical normal, isn't it? And that is why we consider that the net force from the curved surface area of the net force, this is why the net force from curved surface of area of any frustum is in upward direction. Is that clear? So we are going to utilize these concepts. We are going to utilize all these concepts one by one, and let us see how do we utilize this. And we bring our first question regarding that. Let's suppose we are going to once again repeat that question which we did in revision class, but now it will be a little bit difficult one. There is a block, okay, of mass m and height h, okay, which is submerged inside a liquid. Okay, is that clear? And let's suppose this block is fully immersed. Okay, 1 minute. Let me make it till top. This block is fully immersed basically. Okay. The point is the level or the height gap between the surface of the block and between the surface of the water is given as, this one is given as h1 and this is given as h. Are you able to get me or not? Okay, and this is my water having density rho naught or rho. Let us just rho. Okay. So the question is simple. Uh, First, find the following things. First, buoyancy force. Second, tension in the thread. And third, uh, third, net force due to liquid on block due to pressure. Do these questions. Yeah, I can consider. Area of the block is A. How much is that? Okay. Hmm. Let me see. Acha, what is buoyancy force over here? It is density of the liquid row. Volume immersed is fully immersed. So it is area of the block into height h into gravity. Tension. This is my tension, and this is my weight of the block mg, isn't it? And buoyancy force is upwards. So tension is equal to mg minus buoyancy force. Mg minus rho to g. Yes, isn't it? Are you able to get me? Next thing is the calculation of pressure. Achha, you did one silly mistake over here. What is that silly mistake? That actually you try to see there is a pressure from the upward column of liquid in the downward direction. Not only atmospheric pressure. First atmospheric pressure P naught, then the pressure due to this level of water of height H1, isn't it? And then from the downward level of water there is a pressure F2, force F2. From other sides the forces are same. I'll still mention because it's asking due to pressure. So the forces are present from all the sides, isn't it? So for I except from top and bottom surface, all the faces are experiencing same force. So that's the net force from all the other directions is zero except top and bottom. So if I find F1, F1 is nothing but the pressure at top surface into area of the surface. which is rho g h. Height is how much? H1. That is 1 minute. Sorry. Top surface pressure is atmospheric pressure plus rho g h1 into area. Yeah. F2. What is F2? The pressure at this depth. The pressure is at this depth is still due to the upward pressure, isn't it? Yeah. It will add. So it is P naught plus rho g h1 plus h due to the water column into area, isn't it? So net force due to these pressures is F2 minus F1, which is equal to P naught A plus rho g h1 A plus rho g h A minus P naught A plus rho g h1a. So you see that this and this and this and this got cancelled, and F net is nothing but rho g h into area A, which is nothing but buoyancy force. So net force due to the liquid on block due to the pressure is exactly equal to always buoyancy force. Are you able to get me or not? Is that clear? So we got to know so many things about it. Let us go to one more concept, and that we call fraction of object immersed, fully immersed. Huh. Yeah, kind of that. ठीक. चलो इतना जो तक कुछ डाउट, इतना जो तक कुछ डाउट, any kind of doubt? Nothing. Okay, so we are going to discuss how much fraction will be merged. 1 minute just. Yeah, let us see that. Okay. And this is also called as law of flotation in simple terms. Okay, so let us see how does that happens. Let's suppose I have a container. A container is a permanent object in the fluid mechanics. Okay, and a blue color ink is always permanent. So always you should have a blue pen and a container with your hand if you want to become Archimedes. Okay, so look over here. मान लो I just immersed one body. ठीक. अब body का कुछ part ही immersed है. Okay, this much part is only immersed. Okay, so I represent, there are some quantities which I represent. V naught, V as volume of object, total volume of object. Okay, and VIM as immersed volume of object. Is that clear? Now, if I consider that if this body is floating like this way, then it has some weight, isn't it? And it is experiencing some buoyancy force, then only it is at equilibrium. Are you able to get me or not? So at that time, at case of flotation at this stage, buoyancy force must be equal to weight of the object or not? Uh, this buoyancy force is sometimes also called as upthrust. What it is called as? Because the net force is in which direction due to the liquid surface when the object is in contact? Upward direction. Are you able to get me? So buoyancy force is equal to how much? It is rho of the liquid into volume of volume immersed into gravity z, and that is exactly equal to try to understand, it is exactly equal to, if let's suppose the object has density sigma, sigma is the density of object, then weight is equal to mg, so mg can be written as sigma, which is density of object into total volume into gravity g. Now look here, this g and g got cancelled, so the amount of fraction which can be immersed out of total volume is dependent upon density of object divided by liquid, and this is called as law of flotation. What it is called as? Is that clear or not? Is this totally clear? So based upon this, there are many possibilities which arises, and we will talk about that in a much more greater sense. So first thing is, let's talk about the possible cases due to this which appears. Okay, are you able to get me? So basically, let's suppose the first case is if density of object is less than density of liquid. So look over here, if this density of object is less than density of liquid, that means what? This volume immersed will be less than volume of the object, isn't it? Because this is will be a fractional number, isn't it? Are you able to get me? So this means what? What happens? Only the fraction of liquid is immersed. Alright, sorry, only the fraction of object is immersed in the liquid. Now, let's, if I talk about the fraction, take, if I talk about the fraction, then if you look over here, weight is mg, isn't it? Force is buoyancy. So if the fraction of the liquid is immersed, that means what? Buoyancy force means mg is less than buoyancy or not? That means what? The second condition of this, that buoyancy force due to buoyancy is more than weight of the body, is more than weight of the body, and this is called as flotation. What we call it as? Are you able to get me? Second point, okay, consider this to be first point, not the third point. Okay. Second point, if density of object is exactly equal to density of liquid, then what will happen? Tell me. Hmm. Then simple volume immersed will be exactly equal to volume or not? What will happen? The whole rigid body gets immersed in the liquid, or we can say volume immersed equal to volume, isn't it? But that, does that mean where the body will be? It is going to be on top, bottom, or where it will be? It is going to be anywhere where you place it. That's the biggest point. Okay, so this implies the body remains floating. Body is still floating. anywhere you leave the body. Are you able to get me? Means in this container, if this is equal, it can float on top surface wherever you leave it. It can float on here. It can even float on here. Wherever you leave it, the body will float. But the condition is same. Buoyancy force must be equal to mg. Are you able to get me or not? This means, this also implies that force of buoyancy must be equal to weight of the body. Is that clear or not? This is also a flotation with fully immersed volume. Is this clear? Third case. Well, how come it is nothing in fluid mechanics is hypothetical? If density of object is more than, the body starts to the body starts to sink. Means it's not going to float. That means force of, yeah, force, isn't it? That means the body poses an acceleration downwards. How come it will be g? Isn't it is experiencing upward force? So that, yes. So let us consider an object. How come it is pseudo? It's a real force, man. Buoyancy force is a real force. If this is m, okay, let us not call m. It has a density sigma, and it was going inside a liquid. Mg is downwards, but buoyancy force is upwards, isn't it? But since its density is high, it will accelerate downwards. I call this as acceleration net. या फिर g effective. Are you able to get me or not? Yes. So if it is downwards, then equation should be mg minus force of buoyancy, and that should be equal to mass into acceleration a, isn't it? Mg is what? Sigma. Volume of object is v into gravity g minus force of buoyancy is rho, density of liquid. Volume immersed is actually going to be full volume into gravity g is equal to sigma v into acceleration a. देखो तो v v v क्या कर जाएगा? Cancel. Acceleration will become g minus g rho g by sigma, where I can take g common, and it is 1 minus rho by sigma, which is also known as g effective. So this is the acceleration with which the block will accelerate downwards, and this can be also the acceleration with a negative sign if the block has a density less than the density of the object. Are you able to get me? Is that clear? So नया concept. Okay. Okay, so let me give you one more question regarding this. बोल रहा है कि let's suppose on a surface of a liquid, okay, on this surface of liquid I just drop a ball of mass m from the top. I just drop a ball over here. Okay, from its initial velocity is 0. It has mass m. Okay, and it has density sigma. Okay, and the height from which it is dropped is given as h. Density of liquid is rho. Condition is question is find the distance, find the maximum depth, find the maximum depth of ball in liquid. Okay, and assume there is a no loss during collision when sigma is less than rho. बताओ. Hmm. Hmm. बताओ. So today evening we have also a class na, at 9:30 p.m. No, why? Are you going somewhere or? Mm-hmm. Okay. Evening 9:30 p.m. only. Is that fine? 6 p.m. 6 p.m.s become little bit tedious because sometimes I need to go outside. 6 p.m. is the evening time over here. That's the biggest problem. That 9 p.m. 9 p.m. Not 9:30, 9 p.m. Okay, that is fine. Okay, let us do this. So the question is find the maximum depth of ball in the liquid, isn't it? See that. Let us try to see as this ball is going. Tomorrow is Sunday now. No, keep it 9 p.m. 9:30 p.m. because I think work is going on over here. Some work, so that is why, like, it will have a problem. So now look over here. See this. When this ball will travel, see what will happen. This ball will get a maximum velocity at the top surface, isn't it? And this, and at the maximum depth, wherever it appears, where let's suppose it appears over here, at this maximum d max, the velocity will become zero or not. Velocity becomes zero only because of one factor, that when it is going deep down inside the liquid, some kind of retardation, acceleration is working in upward direction, because density of the ball is less than density of liquid. Are you able to get me or not? So this velocity of ball at the surface becomes how much? Simply not nothing like root 2 gh, isn't it? And I told you this is the acceleration for the downward motion. But whenever this rho is more than sigma, this acceleration is going to be in upward direction or not? Yes. So this will be just negative, or if I just resolve this negative sign, it can be simply written as rho sigma by rho. Sorry, rho by sigma minus 1. But this acceleration is in which direction? Upward direction. Yeah. Okay. So simply I can apply now v square is equal to u square plus twice g. Sorry, twice a d max. Yes. Final velocity is 0. Initial velocity is root 2 gh whole square, and that is minus of 2. Acceleration is g into rho by sigma minus 1 into d max. Why this acceleration to be negative? Because it is a retardation. It is what? Is that clear? So the equation will change to what? Simple. The equation will change to 2gh is equal to twice g rho by. So g cancel to 2 cancel, and it is I'll be left with, I can just do the multiplication, and this d max is nothing but sigma into height h by rho minus sigma. This is my d max, which will be reached by the body. Are you able to get me or not? Is that clear? You can even solve this question in a very easy way, like using the work energy theorem. Okay. I can even solve using work energy theorem. Okay, we know that work energy theorem is nothing but work done by all the forces is change in kinetic energy, isn't it? Now, work done by all forces. So see this, the first force is mg, isn't it? Second force is this buoyancy force or not? So work done by mg is what? Simple. Work done by mg is a gravitational force. So work done by mg should be negative, isn't it? But if I just take directional sign, I'm just taking the directional sign. So force is mg, and the total displacement is, I'm taking downward direction as positive. So total displacement is height h plus d max. Correct? Acha. If I'm taking downward direction as positive, then upward direction should be negative, and force of buoyancy is working in upward direction only. So force of buoyancy should be what? Positive, negative basically. And force of buoyancy is what? What is the force of buoyancy? Rho into volume immersed is total volume into gravity g, and it works for displacement only d max, isn't it? And that is equal to change in kinetic energy. Initial velocity was 0, final velocity is also 0. So change in kinetic energy is 0, isn't? So the equation is simply mg is sigma into volume into gravity g h plus d max is equal to rho vg into d max. If you just cancel this v and g and g also, so it's just very simple. Sigma h plus sigma into d max is equal to what is that? Just rho into d max, and this gives us the conclusion that d max is nothing but sigma h by rho minus sigma. So this can be also utilized to find the answers. Is that clear? I think work done is more easier. You can see within two lines we can solve that. Both are correct. Both are. It's on you which thing appears first in the question. Which it depends upon the exam hall now. Which thing will appear in your mind, that you have to see. Okay, you do not have to go through like which thing is not appearing. You have to always think that which thing is appearing first, and on that basis I'll do the question. Okay, is that clear? Okay, 1 minute. Let me check one more question. Uh, 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 Time period. 1 minute first. Then I have one ice water question. Where is that? Okay. I had one ice water question. I don't know where I had lost it. Uh, mg ball density. What is that? Okay, yeah. So let's suppose I'm considering an ideal example. Okay. So let us take uh, that I have a container, and in that I have any kind of liquid, basically water I'm taking. Okay. So I have this water, and this any kind of uh, object or a block is immersed. Okay, got it. So the point is very very simple. Let's suppose if it is the volume of object in simple case, yeah. So total volume V is volume of object, okay, and VIM is the immersed volume, and let's suppose if this is sigma, density of object is sigma, and density of liquid is rho. Okay. Now look over here. We got the equation that volume immersed by volume of object, density of object. Yeah. Yes. Now take an example of ice water combination. Let's suppose if there is an iceberg on the water which is floating. Okay. First case. So look over here. If the ice water is floating, that how much part of the ice should be submerged such that the ice should float? That's a big question now. So actually, it is calculated how much fraction should be inside the water. That is a big question. Okay, so let us see that. If we calculate that, then actually we find that the density of ice is given as 0.9. gram per centimeter cube. While if we calculate the density of water, it is 1 gram per centimeter cube, isn't it? So if we found out, if we find that, then volume of immersed ice by volume, total volume is equal to how much? 0.9. The factor is 0.9, isn't it? So if I want to find that how much fraction of volume should be immersed in terms of percentage, that means it must be equal to volume immersed by volume into 100%, isn't it? So here if I put Vm by V as 0.9, I get how much? 90%. That means if an ice wants to float on water, then 90% of the volume of the ice must be inside the water, then only it will float on the surface. Is that clear or not? And that is why you can find that almost every ice which is formed, it has a very thin layer on the surface of water, but 90% is inside the water itself. Are you able to get me or not? Or either it will float in such a way that 9 means whole volume is submerged, means either this 90% is almost equal to 100% or not. 10% less is there, but that can be managed. Okay. So this is why you will find that the whole ice does not sink. The whole ice is totally on the top surface of water. Are you able to get me or not? So this is what is the main reason. Next thing, let's suppose if I take the case of wood and water case, second case, wood water floating, है ना? So density of wood is given as almost similar for all the woods. I am taking 0.6 gram per centimeter cube. And if you take uh, water, how much? 1 gram. So once again, if you find the fraction, 60% only, isn't it? Is how much? Volume immersed by V into 100%. So that is equal to 60%. So कितना percent रहना चाहिए? 60% of the volume should be inside the water. Next, third case, wood oil case, isn't it? So density of wood is 0.6 per centimeter cube. Density of oil is remember these forms, okay? Remember this. These are memorizing questions, okay? That's why I have written wood water, wood oil, and ice. ठीक? Yeah, you have to memorize. So fraction, I know that, but you have to memorize. So fraction of wood immersed, it is there. Volume immersed by volume into 100%, and that is equal to density of wood by density of oil into 100%. कितना आएगा ये? 0.6 divided by 0.8. That is almost similar to 76%. Is that clear or not? So if someone asks you in which case the wood is immersed more, so you will find that in oil is immersed more in case of water, more in case of water. Are you able to get me or not? So these are some of the best conclusions which we can draw from. Done. So this much is the main concept regarding Archimedes principle, which we should have a basic understanding, which we should have a basic knowledge of that. Now, let us come to one most last question of the day. Then tomorrow, once again, we'll have the Archimedes principle. It's not ended. Now, let us take one example of oscillation. ना तुम एक काम करना एक चीज देना एक वैक्यूम वाला बॉटल लेना है ना और मतलब वैक्यूम नहीं, मतलब उसकी कैप बंद हो, उसमें पानी मत, कुछ भी लिक्विड वगैरह नहीं रहना चाहिए, ओके। एंड उसको क्या करना, इमर्ज करके हल्का सा पुश करके छोड़ देना, वो देखना ऊपर में ऑसिलेट करता है ना, you will find that it is oscillating, isn't it? Same thing I want to do. I have any kind of a block and I placed it over here. The density of the block is sigma and density of the liquid is rho. Okay. The question is simple. If a block of height h, मैं लिख दे रहा हूँ, a block of height h and density sigma and density sigma is floating on in liquid of density rho, is floating in liquid of density rho. Then question is find the time period for a small oscillation of block. Find the time period for a small oscillation of block. बताओ. Find the time period for a small oscillation of block. Oscillation में हरदम you know that you have to write the net force equation for SHM. What is the condition? First step is write F net equation or equation of force in terms of minus of kx. F net should follow this minus of kx, isn't it? Then only it is going to have this particular case of time period. Okay. Hmm. Very simple, Baba. See that. If I displace by distance x, let's suppose I'll have to dip it some distance x, isn't it? Already it has height h. Okay. A block of height h and density sigma. Okay, height h it is saying. 1 minute. Let me think. Uh, let us do one thing. Let us not consider the whole height. Okay. Let us consider that the immersed height is h. But immersed height will not give you the answer. Yeah. Okay, let us consider the whole height to be h. Yes. No problem. That is not required. So if I write the F net equation, what is that going to be? Simple. It will oscillate only because the buoyancy force is more, isn't it? The force of buoyancy minus mg, isn't it? Now, the condition is you have to talk. The first point is we have to define that what is this particular, you can say, the equilibrium point in SHM or not. Yes. So let us talk about that first. That, let's suppose if the equilibrium point is attained at height h1, isn't it? So second step of this, if at depth h1 equilibrium of block is present, isn't it? So if at that depth equilibrium is present, what will be the equation? Simple. Uh, rho into volume immersed area into height h1 into gravity g is equal to sigma into area total height h into gravity g. This is going to be that. This is force of buoyancy and this is my mg, isn't it? So this implies area cancel, gg cancel. So rho a barabar rho h dash, sorry, rho h1 is equal to sigma into h. Is that clear or not? So after displacing distance x, I'll have the force of buoyancy as Fb dash or not. But what is Fb dash? Simple. That is uh, that is rho g, and this will be h1 plus x or not. Yes, that will be my force, isn't it? Force of buoyancy. But that is equal to how much? Minus of mg. That is my net force equation. Are you able to get me? So what is net force? Buoyancy force is this one only. Rho g h1 was original there, and then, acha, I'll have to multiply with area. Then only it will be. Sorry, why I'm multiply. Volume is there. Yes. So it will be multiplied with area. Are you able to get me or not? Now look over here. So F net is equal to simple rho g h1 into area. Rho into h1 is what? Simple. Look over here. We just derived sigma into h, isn't it? So rho into h1 is sigma h. So rho g. So sigma h g into area A minus, sorry, plus rho g x into area A minus mg is nothing but sigma into h into area A into g. So this and this got cancelled or not? Yes. So what is the net force equation? Net force equation is one. I got F net is equal to simple rho g a into x, and that can be treated as k or not. A F net is equal to a. I'll write in terms of minus. Okay, because this is always doing something. So rho g a by mass into x. But what is mass? Mass is nothing minus rho g a. Mass is sigma into volume a into h into x. A cancel. So a is equal to minus rho g by sigma into height h into x, and that is why time period is 2 pi root under m by k. यही होता है ना? इसका ऑपोजिट हो जाएगा sigma h by rho g. Are you able to get me or not? So this is my time period of a small oscillation. So always you have to write what you have to write: F net equation and equilibrium equation. You have to always do only one thing. You have to write the F net for a small displacement, means after displacing distance x, and at equilibrium write the force equation. You will get anything whichever is required for a system. Is that clear? Okay, so this was Archimedes principle. Still some more questions are left, which we will do tomorrow 9:30 9 p.m., isn't it?